So the next one that we are going to talk about is a product rule. You see, this one is another way of solving a problem under differentiation. So I will derive the formulas. Let's derive the formula together. And then we are going to derive the formula using the first principle, the one we just finished now. So we'll start from here. Let y is equal to uv. So here, the function we are dealing with here is u and v. So I will change the derivative of this one respect to u at the same time respect to v. So here I can have y plus changing y. So now this, if I open it, this can be u plus changing u. That's for u. Then for v, we are going to have v plus change in v. I hope you get that. So the one for the u, we write it in terms of u. Then the one for the v, we have it in terms of v. So now let's expand. But note one thing: there's something that we cannot have. There's nothing like u changing u. If you have this, it's always 0. There's nothing like v changing v. This thing is always 0 as well. And I cannot have change u changing v. So please note it. Note these three values. Wherever you have these three, it's always tend to be 0. So we cannot have, meaning if I have u, the derivative can only be maybe changing another alphabet. Maybe if I have u now, I can only have changing v. Or if I have v, then we can have changing u. So whenever you have these three cases, we always tend them to be 0. So now let's expand this one, and we have y plus changing y is equal to u times v, and we have uv. U times changing v, and we have u changing v. Changing u times v, of course, we are going to have v changing u. Then changing u times changing v, we are going to have changing u changing v. You know, I told you earlier, there's nothing like this, so I can remove this one. That's going to be 0. If I remove that one, so here we have y plus changing y is equal to uv plus u changing v plus v changing u. So the next one is, I can collect like time to make my changing y as the subject, which is if I do that, we have changing y is equal to uv plus u changing v plus v changing u. So this is y. When the y comes here, we are going to have minus y. So from here, we see that our y is equal to uv. So if I put the value of y there, that means that we have changing y is equal to uv plus u v plus v du minus our y is uv. So we can see this is uv minus uv. That's going to be 0. So what we have left now is our changing y. The y is equal to u changing v plus v changing u. Remember the law, and after that we divide all through by what? Changing s. So divide all through by this. So you can see the formula. So the formula is dy dx is equal to u dv dx plus v du dx. So this is our formula for product what? For product rule. So if you are solving a problem using the product rule, just take, when you have a 2, let the first one to be u, let the second one to be v, or anyhow you like it. Then differentiate the first one, the second one, and apply the formula. So let me put the formula here. So for the product rule now, we derive now that dy dx is equal to u dv dx plus v du over dx. So this is the formula for product what? For product rule. So let's see some examples there. And let's see how we are going to make use of the formula. Let's look at this one. They said, given that, or find the derivative of the following. Maybe I should write like 3 examples. Find the, or let's solve it one by one. If y is equal to, let's say we have x squared plus 5 and x plus 2, they now say find dy dx. So I can just apply the method. So in a simple way, I will let this one to be u, and I will let the second one to be v. I hope you are getting this right. So let the first one, let u equal to x squared plus 5 as in the first one, and let v to be equal to x plus 2, which is the second one. Are you following? Now, so the next step is I will differentiate the first one and I will differentiate the second one as well. So u and x, here we have the u over the x. You know, I already told you how to differentiate. So the differential of x squared to come forward, and we have 2x, and we know that the differential of constants is going to be 0. So here we have phi and x, and we have dv dx. You know, the differential of x is going to give us a 1, and the differential of 2 we are going to have what? 0. So now, what's our formula? Formula is dy dx is equal to u dv dx plus v du dx. So now we have dy dx is equal to our u. Look at our u here. Our u that we have here is x squared plus 5. dv dx is 1. We have dv dx to be 1 plus v. Our v that we have here is x plus 2. du dx is 2x. So now here I can have dy dx is equal to 1 times this, and we have x squared plus 5. Even if I open this one with 1, I will still have the same result. So now x times 2x, we are going to have 2x squared. Just like I'm multiplying the powers together, that is x times x, that's going to be x squared. Then the one we have here is 2 times 2x, we are going to have 4x. So let's check the one that have the same power so that we can add them together. So here I can have dy dx is equal to now x squared plus 2x squared. Of course, we are going to have 3x squared. Then we have this one 2 here plus 4x, then plus 5. I hope you are following, right? Yeah, good. Let's see another problem that's have another. Let's see, maybe I have to change the same questions. Let's change the questions and write another one. Maybe they say, given this, you see how the question comes will determine which method are you going to apply. Is it going to be first principle, or general method, or function of functions, or any other functions being mentioned? So let's say I want to bring another problem. Let's say we have x5 x squared plus 3 raised to the power of 2, for example, or let's say 4. And they say that as you use 4, as you apply product rule to solve this one. So the same way, I will let the first one to be u, and I will let the second one to be v. So u here is equal to x raised to the power of 5, and v here is equal to x squared plus 3 raised to the power of 4. So I will differentiate the first one as well. I will differentiate the second one. So u and x, I will have du over dx. So the differential of this, you know, that's going to be 5x4, right? So now v and x, and we have dv dx is equal to the differential of this, and we have, you know, I give you the simple method of how you can solve this one. Function of function, the power come forward 4, then we are going to differentiate what we have inside the bracket. Differential of x squared, that one is 2x. So differential of 3 we have 0. Then we write the equation again as x squared plus 3, then 4 minus 1. So here I can have this one to be, you know, 2x plus 0. What are we going to have? 2x. So 4 times 2x, we are going to have 8x, then x squared plus 3 raised to the power of 3. You get that? Good. So now I have du dx, at the same time we have our dv dx. So now the formula dy dx is equal to u dv dx plus v du dx. So now, so here we can have this one to be our u from here. What's our u from here? Our u is x5, let's raise to the power of 5. dv dx, we have dv dx to be this. dv dx is 8x x squared plus 3 raised to the power of 3 plus our v is x squared plus 3 raised to the power of 4. Then du dx, we have du dx to be 5x4. So now, if I want to open, so this times this, you know, this is x5, this is 1x. I can add that one together. x5 times x, I can have that one to be x8, then x squared plus 3 raised to the power of 3 plus x squared plus 3 raised to the power of 4, and then we have 5x4. So now, it depends on how they leave the result. If you like, you can still go further. Check here. Here I have x4 and x6, and I have x raised to the power of 4 here. You can see we can factor out something. I can factor out x raised to the power of 4 because it's common to the 2. At the same time, I have x squared plus 3 raised to the power of 3 here. Then we have x squared plus 3 raised to the power of 4, which means this one is also common. I can also factor that one out. X squared plus 3 raised to the power of 3, because it's here at the same time, also appear here as well. So that means since I've already removed x raised to the power of 4 here, what we have left here is 8x squared. You know, if I remove 4 from 6, we are going to have 2. So now we are going to have 1 left here. So here we have x squared plus 3, then we have 5. I hope you get it right. You know, we have already removed our x4. So now you can open the bracket of this. So here we can have this one to be x4 dy dx to be equal to x raised to the power of 4. Then I have x squared plus 3 raised to the power of 3, 8x squared, 5 times x squared. We are going to have 5x squared. 5 times 3, we are going to have 15. Can you see that? We only factor out what we have in common from the first side and from the second side as well. So here, we are going to have dy dx is equal to x4 x squared plus 3 raised to the power of 3, 8x squared plus 5x squared. We are going to have 13x squared, then plus 15. So our dy dx, we have the value to be x raised to the power of 4 of x squared plus 3 raised to the power of 3, 13x squared plus 5. So let's check some material from Federal University Juicy and see some problem using product rule. Okay, I think we have solved many questions, many examples there. Let me just bring one. Let's bring this one. They said we should use product rule to solve this. Question from Federal University Juicy. Jigawa. I don't say that. The school is one of the best. So, because I'm one of their products, they said y is equal to root of x, x4 plus 3. So we have to use product rule to solve this one. So I will still solve with the same process. I will let the first one to be u. At the same time, I will let the second one to be v. So this one I can say let the first one we have is root of x. Let u equal to root of x. Then second one, let v to be x4 plus 3. You know, if I have root of x, this is nothing but x raised to the power of 1 over 2. Then here, I will differentiate the first one. At the same time, I will differentiate the second one too as well. So u and x, I will have du dx is equal to differential of this, I will have 1 over 2x, 1 over 2 minus 1. You remember that, right? Then, so here we have du dx is equal to 1 over 2 minus 1, normal fraction. So here we are going to have this one to be x raised to the power of minus 1 all over 2. So now, normally we can change this to normal fractions using indices. 1 over 2 multiplied by 1 over x raised to the power of 1 all over 2. So here I can write this as 1 over 2 root of x. So second one, I have v and x. So here we can have dv dx. So differential of x raised to the power of 4. Of course, we are going to have 4x cubed. Differential of 3, that's going to be 0. So now, applying the formula, you know that the formula is dy dx is equal to u dv dx plus v du over dx. So now let's substitute the values one after the other. So our u is root of x, means I can have dy dx is equal to root of x So dv dx, we have the value to be 4x cubed plus v. Our v is x raised to the power of 4 plus 3. Then du dx, we have du dx to be 1 over 2 root of x. So this one, we can still apply indices to change this one, because if you have root of x, root of x, it can be written as x raised to the power of what? 1 over 2. So here, I can have dy dx of this one to be x raised to the power of 1 over 2, and we have 4x raised to the power of 3. So x raised to the power of 4 times 3 plus 3 plus 1, and we have x raised to the power of 4 plus 3, all divided by 2 root of x. Then indices for this one, I can have this one to be dy dx is equal to, this times this, I'm going to have 4x. The power of this one is 3, the power of this one is 2. That's 1 over 2 plus 3. Indices, we take 1, 5, then we add the power together. So now here, I can have x4 plus 3, all divided by 2 root of x. So here we have dy dx is equal to now 1 over 2 plus 3 fractions. The x sum of 2 and 1 is going to give us 2. So 2 in 2, we are going to have 1. 1 times 1, we have 1. 1 in 2, we have 2. 2 times 3, we are going to have 6. The 1 plus 6, that's going to give us 7 over 2. So here, I can have this one to be 4x raised to the power of 7 over 2, then plus x4 plus 3, x raised to the power of 4 plus 3, all divided by 2 root of x. So that's what we have for the product rule. So when you are giving a problem under the product rule, like the first one to be 1 w. So if we, let me add this one too. Thank God I remember this. It can be in form of 3. If it's coming in form of 3, let me just solve one question under that. I thank God I remember. If it's coming in form of 3, it's still the same thing. Maybe we have 3. Instead of having 2, we are having 2. That's why we are using u and v. Let's say it is 3. Yeah, we can still solve that one. Let's say I have something like this. Let's say we have x plus 1, x plus 2, x plus 3. Like if I have 3 like this. So it can be solved as well using that same method. I can say let this one be u, v, w. You'll be wondering how are we going to do this one? Yeah, we can do it. Look at the formula. If I want to do this time, it's going to be dy dx. Look at it. It's going to be uv. I manipulate u and v together. So the other one is going to be what? dw over dx. Then plus uw. So this is our uw. What's going to be the functions? Their derivative? Yeah. Going to be dv dx. Then plus vw. Then we have du over dx. You can see that, right? So if I have uv, then the derivative is going to be w. For uw, that's going to be v. Then for vw, that's going to be du. So here now, u is equal to x plus 1, v is equal to x plus 2, w is equal to x plus 3. So I will differentiate the first one, the second one, and the third one. So here we have du dx. Differential of s is nothing but 1. Differential of 1 is 0. dv dx as well is also 1. The w dx2 is also what? Is also 1. So now we can just plug in the formula there. We have dy dx is equal to uv dw over dx plus uw dv dx plus vw, then we have dv all over dx. So now, for u, what do we have for u from here? Our u is x plus 1. Our v is x plus 2. So our dw dx, we have to be 1. Our u, again, is x plus 1. Our w is x plus 3. Our v, again, is x plus 3. Our w, our v is x plus 2. And our w is x plus 3. And we have the other one to be 1. So if I expand this one, x times x, we are going to have x squared. X times 2, we are going to have 2x. 1 times x, we are going to have 1x. 1 times 2, we are going to have 2. So here too, x times x, we have x squared. X times 3, we are going to have 3x. 1 times x, we have 1x, which is x. 1 times 3, we are going to have 3. So the same thing also applicable to this side. X times x, and we have x squared. X times 3, we are going to have 3x. 2 times x, we are going to have 2x. 2 times 3, of course, we are going to have 6. So here now, let's add the one that has x together. X squared plus x squared plus x squared. That is going to give us 3x squared. So now 2x plus 1x. 2x plus 1x, that is going to give us what? Yeah, 3x plus 3x, 6x plus 1x, 7x plus 3x, 10x, then plus 2x, we are going to have 12x. So this is plus 12. 2 plus 3, that's going to be 5. 5 plus 6, that's going to be 11. So that's all about for the product what? For the product rule.